We have some snow out on the ground right now. Not all that much, but let's say that tonight we get a snowstorm. 30 centimeters of snow. All over town, 30 centimeters of snow. You guys wake up, you're all happy because you think school's canceled. And then Braden, his mom, says, well, what are you so excited about? You got to shovel the driveway. And Jordan, her mom says, Jordan, what are you so excited about? You got to shovel the driveway. Let's pretend Braden and Jordan live right beside each other for a second, okay? So they have identical driveways right beside each other. They have the exact same amount of snow in there. They both at 8 o'clock in the morning go outside to shovel the snow because their mom said, go outside and shovel the snow. Earn your keep. So they start shoveling, and Jordan, an hour later, is finished shoveling her driveway, full of a foot of snow, right? 30 centimeters of snow. Braden, 4 hours after that, finally finishes up. Who's done more work? Jordan or Braden? They both shovel the same amount of snow, right? Jordan did it quicker. Oh, but wait, Braden did it longer. So who did more work? It's equal. They both did the same amount of work. But we have to have a way of quantifying how quickly they did that work. Right? If somebody comes by and knocks on my door and says, hey, I'll shovel your driveway for 20 bucks, I don't care how quickly they do it. It takes an hour, it takes 3 hours, it doesn't make any difference, right? It's going to cost me $20 for the amount of work that they do. I'm paying $20 for that job, for that amount of work. But if I'm paying them by the hour, 15 bucks an hour, let's say, to shovel my driveway, then I do care how quickly they do the work. I don't care how much work needs to be done. I care how quickly that work needs to be done. Well, work is a measure of the change in energy of Jordan or Braden or whatever it is that's applying the force over a certain displacement. Power is the rate at which we do that work, the rate at which energy is used up, or the rate at which work is done. Now, anything that is a rate has time on the bottom. You remember that velocity was the rate of change of position, delta d over delta t. Acceleration was the rate of change of velocity, delta v over delta t. Power is the rate at which work is done. So power is going to be work over delta t. Or you could say delta E, change in energy, over delta t. What do you think the units are going to be for power? Take a look at the equation here. Tell me the units, yeah? Yeah, let's say joules per second. Work is in joules, time is in seconds. But there is another simplification of that. Another set of units that we can use that means the same thing as a joule per second. What do you think it is? What is that other set of units that can be used for power? What is it? Kyle? No. What is that other set of units, Brogan, that can be used for power? That would be the equation. What is that other set of units that can be used for power? Watts. I just told you. What is the other set of units that can be used for power? 1 joule per second is a watt. Now, normally at this point we do a sample problem that's written on the board. This time we're not going to do that. This time you're going to do a sample problem that's real. Okay? The question is, the sample problem is, what is the power output of your legs? What's the power of your legs? Here's how we're going to measure the power of your legs and use that as an example problem. Okay? You're going to run up a flight of stairs, and you're going to time yourself running up that flight of stairs. You're going to see how long it takes you to run up the flight of stairs. You're going to measure the work done by you as you run up the flight of stairs, and then you're going to divide the work done by you, divided by the time that it took, and you're going to get your power in watts. Now, how exactly are we going to determine that? Well, the time is easy, right? You start at rest at the bottom of the stairs like this, ready to go. You press start on your phone, you run up the stairs, and you press stop on your phone when you get to the top of the stairs. Time's easy to measure. But how do we measure the work done in going up the stairs? Well, work is F times D. That's not the easiest way to measure the work in this case, though. The easiest way to measure the work in this case is to say that W is equal to delta E. Remember, it's both, right? F times D and delta E. What type of energy do I have when I'm done? When I reach the top of the stairs and I'm Breathing heavy because I'm out of breath up there. I got what? Potential. So my final energy would be potential energy. What type of energy would I have when I'm standing there at the bottom, all excited because I think I'm going to beat everybody else in the class? What kind of energy do I have now? Ready to go? Nope. Nope. None. I'm sitting there. I'm standing there, right? So my initial energy would be 0. So what I want you to do here is to take your mass in kilograms. By the way, if you don't know your mass in kilograms, take your weight in pounds and divide it by 2.2. Okay, so if I weigh 150, let's say I weigh 220 because that would make the math easy. I don't. But if I did, then I'd say 220 divided by 2.2 gives me 100. My mass would be 100 kilograms. Okay? So your weight divided by 2.2 if you don't know what your mass is in kilograms now. G is 9.81 meters per second squared. And H, the final height, will be 3.0 meters. You're going to run up the first flight of stairs right out here by the languages wing. You know where it goes around the turn and then goes up a couple more stairs? You're not going to go up those other stairs. You're just going to go to the first turn. That's exactly 3 meters. That's defined as 1 story. A 1-story building is 3 meters high. Okay, if you have a 10-story building, it's 30 meters high. So that's why the change there, that's why they go around the corner there, is because that's 1 story. We know that's exactly 3 meters. We know gravity. You need to know your mass. Take mgh and let's divide it by how long it takes you to go up there, and we'll see what your power is in watts.